Hello, everyone. So my name is Siyu. So today I'm going to present a paper between like our kind of a team member here, talk about like basically how to get your feedback for the ACSP conference. So first of all, I am an assistant professor at Texas A&M University. I will be discussing my research on plant integration for urban extreme heat, evaluating the impacts of plants at multiple scales in Tokyo, Japan. Um, we have a really fantastic team on this paper. The co-authors are Dr. Dongying Li, Dr. Yuzhong Kim, Dr. Bob Brown, Dr. Sarah Guston, and then King Long Lei from Texas A&M University. We also have a fantastic team from Tokyo University, Dr. Yokohari and Miss Nemoto. If I get your name wrong, please forgive me and let me know what's the right way to say it, and I will do a better job at the conference. Well, with special thanks to the support from the Department of Homeland Security, National Academy of Science, and also Texas A&M Global Engagement Program to support our project and also our work. So do a quick introduction. Combined by the climate change, extreme heat is an increasingly concerning problem in many parts of the world in terms of the frequency, intensity, and also length. And as far as you can tell from the NASA kind of map here, Tokyo, the land surface temperature is kind of high. Well, this is our study area. So we basically study the Tokyo extreme heat in terms of policy attention on the extreme heat kind of issues. So we also know that the extreme heat is kind of affecting us in a different dimension, individual level and also the community level. Especially its impact can be amplified when community land use plans fail to work together to reducing vulnerability. A well-interpreted network of plan that safeguards the natural environment also build resilience and can reduce the extreme heat loss. So what is a community network plan? So most community have a comprehensive plan, hazard mitigation plan, open space plan, also transportation plan, and then extreme heat guideline as well. But oftentimes they are in conflicts. They're not communicate very well with each other, especially the hazard mitigation planning world is as the most disconnected from other type of urban planning initiatives that actually influence the development happened in the high hazard area. So basically, this is what we call the planning conflicts. So this study is trying to develop a methodology named the Plan Integration for Resilience Scorecard for Extreme Heat to answer the two research questions. So first, how interpreted is Tokyo Plan Network with regard to reducing vulnerability to urban extreme heat? And secondly, to what extent does Tokyo Plan Network target the communities most exposed to urban extreme heat? To address those two research questions, we basically extend the plan integration for resilience scorecard methodology in a more thermal comfort lens. So this is a three-phase methodology. So the first phase is to delineate planning districts and hazard zones. Phase two is to determine different types of community vulnerabilities, physical, social vulnerability, environmental vulnerability. Phase three is to spatially evaluate policy scores, policy attention on extreme heat in Tokyo. And then here is a detailed version of phase one, delineate the planning districts and hazard zones. So we apply the comfort model to testing the heat exposure. And then basically it is a heat index based on the energy budget theory that actually measure the human kind of a thermal comfort for a person. So we provide a comprehensive heat hazard assessment at the city scale to capture the spatial variation in human outdoor thermal comfort. Especially, we have a comprehensive way how to measure the heat exposure by including the land surface temperature, air temperature, wind speed, solar radiation, and also Google Street View image-based the sky wheel factors into the whole holistic way to measure the exposure of the heat in Tokyo as a whole. So, and then after that, we spatially aggregate those heat exposure data at the wall level. So there are 22 wards in the Tokyo area. So, and then we divide them into two types of hazard zone. The first one is the heat danger zone, which is the most dangerous area. And the second one is more like heat cautious zone. So it's the secondary that heat danger zone. So based on those two different danger zone of extreme heat, we're going to evaluate policy based on those two different zones. So here is a version to show you the phase 3 scored network of plans. So we spatially evaluate 33 plans in Tokyo, including the national level, national spatial strategies, national land use plans, the city level Tokyo master plan, and then also Tokyo land use plan, Tokyo urban heat island guidelines, and so forth, and ward level 23 ward level master plan. We especially thank Mio for help us do this type of analysis and also translation. So after whole kind of analysis, each policy we will assign positive 1, negative 1, or 0 based on its likely effect on heat resilience, heat vulnerability of each of the area, each of the ward in Tokyo, 23 wards, spatially assigned scores. And then we allocate them together among all of the policy within plans, and then 33 plans. And we will get a composite policy score map like this, as you can see. So overall, there are several key findings. The overall policy scores, let's take a look at the composite policy score here. The composite policy score for 33 plans from the national level, city level, and ward level plans region from positive 55 to positive 112, which is really good. Apparently, they did a great job. However, the higher scores in the heat cautious zone than the heat danger zones, which means we find that this is a big mismatch. So those policies fail to prioritize the zones needing the most policy attention, which is the heat danger zone, but they paid more attention to the heat cautious zone. This is the overall policy score as a basically overview. And let's take a look at the detailed plan scores. So basically from this diagram, we can see that this is a plan score by different administrative scales. So this table shows us from the national level plans, city level plans, and the ward level plans. They are kind of mean policy scores for each of plans in Tokyo. So the darker orange shows the result of the heat danger zone, which is the most dangerous areas in terms of heat exposure. And then the lighter orange area shows the heat cautious zones results. So from this result, we can see that among the national level plan, city level plan, and also ward level plan, plans at all scales, 3 different scales, give greater attention to the heat cautious zones. And then there are 3 plans, even though the whole network plan score really high, really well, and really positive, really interpreted, there are still 3 plans shows negative results. They are national level land use plan and also national level budget plan for local optimization, and also city level plan, the Tokyo master plans. And we also find that policies trying to preserve and create green-blue network, enhance environmental performance, and address hazards, specific types of hazards, help to create a really important role in vulnerability reduction. So basically, the biggest finding from now, we find out, there's a mismatch, right? The policy attention do not came to the right place. But we want to say why. We want to also see why. So we provide a case study in 2 of the wards in Tokyo. They are Nakono and then Tushima. So basically, we find that we did a deep dive analysis on the policies in those 2 wards, find that the reasons are the policy mismatch. They are foreseen from those policies. So we find that within those 2 wards, they are among the highest heat exposure, but they are among the lowest policy attention among all of the 23 wards in Tokyo. That's why we select those 2 wards to do the analysis. So we find there are 4 really important CM in the danger zone of those 2 wards. We find a lot of policy actually raise density within that area in terms of development pressure. They also do a lot of facilitation of rebuilding, revitalization of existing structure in those 2 wards, danger zone in the wards as well. And they're also trying to enhance housing supply. They also would like to establish a lot of functional center in the heat danger zone in those two wards as well. In another sense, we also find that policy failed to target the most important characteristic that actually impact the heat exposure during our analysis in the comfort model, which are they're only 5% of the total policy kind of pay attention to those two words, pay attention to lower the three real factors. Only 1% of the policy mentioned talk about like lower the building real factor as well. Maybe that's also why making contribution to the mismatch as well. So basically, there are several conclusions of this study. Overall, in the Tokyo Plan Network in general, pays attention to and is also really well integrated in reducing heat vulnerability across all those 33 plans in Tokyo. And we find that policies are really critical for heat resilience. There are such as they come with the preserve and the create a green-blue network. They contribute also trying to enhance the environmental performance. They also directly address different types of hazards in neighborhoods and communities as well. And then the third kind of finding for this study is we find a mismatch between policy attention and also heat exposure. So there are many great vulnerability reducing policy actually fail to benefit the most exposed community within Tokyo, this study. So if you're interested in the plan integration for resilience scorecard, here is our website, theplanintegration.com. So this is the home for the plan integration for resilience scorecard. It showcases the research, community engagement, and education. Thank you so much for your attention. I'm looking forward to your feedback and also suggestions. And this is supposed to be a 10 minutes presentation. I think I do a great job, keep the time, just to hold for 10 minutes. Thank you so much.